Okay, I'm going to go ahead and give 2 or 3 practice problems for most of the topics here. This is some extra practice for Unit 1. Let's go ahead and start off with this graph. I've got 3 of them. So my recommendation for your extra practice time would be to listen to what the question is going to be. As soon as you hear what I'm asking you to do, pause the video, give it a shot on your own, restart the video when you are either stuck or have an answer. That way you can either hear the explanation if that's what you're needing, or fast forward to the answer if you're just needing to check the answer because you're pretty sure you did it right. Okay? So for these first 3 graphs, we are going to be looking at what is the domain and range, and are we one-to-one or onto, neither or both. Right? So again, domain and range, one-to-one, onto, neither, or both. And for this one, let's do our domain and range in inequality notation. Okay, so if you haven't paused the video, go ahead and do so. And let's check this. So domain and range in inequality notation. So my domain, I'm looking here at x values. My first x value as I look at my graph is over here at x equals negative 1, 2, 3, 4, 5, 6, 7. Because this is a whole, we are just going to be less than, not less than or equal to. We have our x. And then you're going to be working your way across going, where do I not have x values? Where is there an asymptote or a hole or a break in the graph, something where an x value is missing? But as we work our way across, we have x values all the way, negative 2, negative 1, 0, 1, 2, 3. Looks like the possibility that there is an issue. I do see a hole here, but if you notice, we still have a point down here. And so I've still got domain. I still have x values all the way to this point, which is at 1, 2, 3, 4, 5, 6. And because I have a coordinate point there, this is less than or equal to. Okay, range are y values. Okay, so my lowest y is down here at negative 1, 2, 3, 4, 5, 6, 7. And this has a coordinate point, so it is less than or equal to. Working your way upwards, you're looking for where do I have any missing values. So break in the graph, a point, an asymptote. And right here, in this region, we have a place where I have no y values. Okay? And so that is a place where I am going to have to cut to show that there is nothing in that interval. And so I'm going to go ahead and cut first at 0, and there's a point. And then it's going to restart at 1, where there's a hole. So no equal to. And then working your way upwards again. Looking for anywhere else where we might not have a y value. Looks like maybe at y equals 3, but I've got a point over here at y equals 3, so I'm good to go. And I go all the way up until 5. And there is a coordinate point there, so it's less than or equal to. Okay, so is this one-to-one onto? Okay, well, to be one-to-one or onto, you first have to make sure you're a function. Looking here, my graph does pass the vertical line test, so I am a function. So it's possible to be one-to-one or onto, or neither or both. Nice thing about the graph is we are definitely onto. To be one-to-one, I have to pass the horizontal line test. Well, unfortunately, right in here, I don't pass the horizontal line test, so I am not one-to-one, I am just onto. Okay? Okay, number 2. If you feel good with that one, you don't have to do the others, right? Fast forward, find the ones that you need. So you need to practice. Okay, but let's go ahead and give this one a shot next. Again, we are doing domain and range, and then one-to-one or onto. Let's do domain and range this time in interval notation. Okay, if you haven't already, go ahead and pause the video, because I'm going to explain domain and range. Domain, x values. The smallest x value in this region is negative infinity. Remember, negative infinity and infinity are never a bracket. They're also never an equals for inequality. Okay, but we're negative infinity. And then we're going to work our way over looking for any interruptions in the graph, and we have a giant interruption right in here. There are no x values anywhere in that region. Okay, so we have to make sure we cut there. This is at x equals -2. And because we have a point, it's a bracket. We restart again at x equals 3, which is a parenthesis, and we go the rest of the way. Okay, my range are my y values. The smallest y value for this graph is down here at -3, and there is a point, so it's a bracket. And I work my way upwards. I've got a hole here that could potentially be an issue, except that I have a point over here to compensate for that hole. So I keep going all the way up to infinity. Okay, 1 to 1 and on to. Again, to be 1 to 1 or on to, we do have to be a function. Looking at this does pass the vertical line test, so we are a function. It is definitely onto. That's the nice thing about a graph. The question is it 1 to 1? Does it pass the horizontal line test? Well, no. Everywhere in here, it does not. So we are not 1 to 1. Okay. And then I've got one more for those who are looking to try one more here. Okay. Go ahead and pause the video. Give this one a shot. Again, domain, range, function, onto, 1 to 1. Let's do our interval notation. Okay, domain and range in interval notation. Domain are x values. My smallest x value is here at -1, 2, 3, 4, 5. And there is a point there. And then I'm going to work my way upward looking for issues. I notice I've got a break in the graph right here. So I need to make sure I compensate for that. So this goes up to 0, and then that's a hole, so we are a parenthesis. We restart again at 1, and we go all the way up. I'm sorry. I made an error. Let's go ahead and erase that. I started looking at range. We will get to range. Let me restart. Revamp. Okay. Domain. Domain, ladies and gentlemen, we do start over here at -5 for my domain. And then I work my way sideways looking for an issue. It looks like I do potentially have an issue here at -2, but I have a point that compensates. Okay. And then so I can keep going, I keep going. Right here at x equals 2, I have a hole and I have no point anywhere on x equals 2, so I do have to cut it at 2. Since there's no parenthesis, it's a point. Or, sorry, since there's no point, it's a parenthesis. And then we restart again immediately at 2 with that parenthesis. And we go all the way over here, which is at x equals 1, 2, 3, 4, 5, 6, 7. And there is a point there. And so that is a bracket. Okay, range. Now we're dealing with range. Okay, so my lowest range here is down at -1, 2, 3, 4, 5, 6, 7. And there's a point there, so that is a bracket. I'm then going to work my way upwards. I notice I have the split in the graph here, so I do have to cut it at 0. There's no point at 0, so it's going to be a parenthesis. And then we restart again at 1, and so that is going to be a parenthesis at y equals 1. And we work our way upwards till we get to y equals 1, 2, 3, 4, 5. And y equals 5 has a point, and so it's a bracket. Okay? Are we a function 1 to 1 onto? Well, I passed the vertical line test, so I am a function. I am definitely onto. Do I pass the horizontal line test? Nope. Right in there, I do not pass the horizontal line test, so I am not 1 to 1. Okay? Okay, next up, we have some maps. So we can practice that again. Okay, so on the maps, I'm asking you to identify, are we a function? If so, are we 1 to 1 and or onto? So are we a function? Are we onto? Are we 1 to 1? Are we neither? Are we both? Okay? So go ahead and pause the video. Give this one a shot. Okay, we have an issue here. To be 1-to-1 or an onto, we do have to first be a function, and right here I have an x, a repeating x, an x value that has the two different y's, one that's going to 1 and one that is going to 3. So if I plotted those 2 points, 3, 1 and 3, 3, I would not pass the vertical line test. So since I am not a function, then I can be neither 1-to-1 nor onto. Okay? 2 more of those. Next up, same question. Am I a function? If I am a function, am I 1-to-1, onto, neither, both? Go ahead and pause the video, give this one a shot. Okay, so am I a function? Well, I have no repeating x values, so yes, I am a function. Am I 1-to-1? Well, to be 1-to-1, each x has to go to exactly 1 y. Sure enough, I am 1-to-1. And last but not least, am I also onto? Because remember, it is possible to be both. Well, unfortunately, as we look here, we do have a 5 that does not go to a part of the domain. To be onto, each part of the range must map to some part of the domain, at least one part of the domain. And that 5 does not map to any part of the domain, so I am not onto. I am just 1-to-1. Okay, one more if you want this one. Same question. Am I a function? If I am a function, am I 1-to-1, onto, neither, or both? Go ahead and pause the video. Okay, here we go. I have no repeating x values, so I am a function. Am I 1-to-1? Well, to be 1-to-1, each x has to map to exactly 1 y. 1-to-1, 1-to-1, 1-to-1. I am 1-to-1. Am I onto? To be onto, every part of my range must map to at least one element of my domain. Well, -18 maps, -8 maps, and 7 maps. So in this case, I am both. Okay. Okay, so let's go ahead and get into some graphing here. So I'm going to group these by function family so that if you are trying to practice one particular function family, you can fast forward the video or rewind the video, whatever you need to do to find the function family that you are trying to practice. Okay. Let's go ahead and start ourselves off here with a quadratic. And I have 2 or 3 of each. Okay. So we have y equals 3/2 times the quantity of x minus 2 squared minus 1. Okay, go ahead and pause the video, give this one a shot, restart it when you either have an answer or are needing to hear an explanation. Okay. So here we go. To graph this one, we need to turn it into our descriptive form. So let's add this 1 to the other side. Y plus 1 equals 3/2 times the quantity of x minus 2 squared. Pulling out my HK, my vertex. My x is going to be positive 2. My y is going to be -1. And with quadratics, remember, we're thinking up A over 1, up A over 1, or down A over 1, down A over 1, if that's the case, or as the case may be. In this case, since we are positive, we're going up. So this is going to be up 3/2 over 1 when I graph it. Okay? So then let's go ahead and give ourselves a little graph here. My vertex is at 2, -1, and I'm going up 3/2 over 1, or up 1.5 over 1 if you prefer that. And remember, that pattern does not keep going. I know I said up 3/2 over 1 several times, but it's because I was trying to get that A over 1 sound into our ear. But with a quadratic, because it is curved, that pattern only occurs the first time on either side of our vertex. And so don't keep going up 3/2 over 1 after these 2 points. Okay, and then connecting that, we've got our quadratic. Okay, let's go ahead and do another one. Another quadratic here. We have y equals -4 times the quantity of x plus 3 squared minus 2. Go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, let's go ahead and turn this into our descriptive form. Y plus 2 equals -4 times the quantity of x plus 3 squared. Adding this 2 over to the other side. Okay, then we're going to go ahead and pull out our vertex. My x is going to be -3, my y is going to be -2. And it is a quadratic, so we're thinking a over 1. In this case, down 4 over 1 on both sides. So down 4 over 1 on one side, down 4 over 1 on the other. Okay, let's go ahead and sketch this. Initial point at -3, -2, 1, 2, 3, 1, 2. And then we are going down 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. We've got a pretty steep quadratic here. That -4 tells me I'm going to be fairly steep. Okay. Okay, last one for the quadratics. We have y equals 3/4 times the quantity of, that's a 4 by the way, sorry, 3/4 times the quantity of x minus 2 squared plus 5. Go ahead and pause the video, give this one a shot. Okay, descriptive form, subtract this 5 over, we have y minus 5 equals 3/4 times the quantity of x minus 2 squared. That means my x in my HK, my vertex, is going to be +2, my y is going to be +5. I am a over 1 for a quadratic, so my a is 3/4 over 1. Okay, so let's go ahead and sketch this. Initial point, 2, 5 is here. Okay. And then up 3/4 over 1. Okay. And we've got our function. Okay, so those are quadratics. Next up, we have our absolute values. Okay. So 3 of these as well. First, we have y equals 5/2 times the absolute value of x minus 3 plus 1. Go ahead and pause the video, give this one a shot. Okay, turning it into a descriptive form, let's subtract that 1 over. You get 5/2 times the absolute value of x minus 3. My vertex is at +3, +1. With absolute value, we do have a consistent slope because linear absolute values are lines on either side, so we can think up 5 over 2. So let's go ahead and give this one a sketch. Initial point at 3, 1, 1, 2, 3, 1. And then I'm going up 5 over 2. So 1, 2, 3, 4, 5 over 2. And 1, 2, 3, 4, 5 over 2. And technically speaking, that does keep going. But I'm going to go ahead and call it with those 3 points. That 5/2 keeps going through the graph. Okay. Second one, we've got y equals negative absolute value of x plus 7. Go ahead and pause the video, give this one a shot. Okay, descriptive form. Well, it's already in our descriptive form. We have nothing to add or subtract over to the other side. So, ordered pair. My HK, my x coordinate is going to be negative 7, and my y coordinate is going to be 0. And then this is an absolute value, so we do have slope. Our slope here is negative 1. So we're thinking down 1 over 1. Giving this a sketch. Actually, I'm going to have to rework that because we have to make it over to negative 7, 0. So let me do my sketch over here. Okay, there we go. Okay, so initial point, vertex at negative 7, 0, 1, 2, 3, 4, 5, 6, 7, and 0. And then I'm going down 1 over 1, and down 1 over 1. And then this is an absolute value, so technically that down 1 over 1 does continue. And so you have your V. Okay. Okay, one more of the absolute value family. We have y equals negative 3 times the absolute value of x plus 4 minus 1. Go ahead and pause the video and give this one a shot. Okay, descriptive form. Let's add this 1 over to the other side. Y plus 1 equals negative 3 times the absolute value of x plus 4. Initial point, x is negative 4, y is negative 1. We are absolute values, so I do have a slope. My slope is negative 3, so we're going down 3 over 1. Okay, initial point, negative 4, negative 1, and then down 3 over 1. Okay, and again, it's absolute value, so technically that pattern keeps going. And you've got your V. Okay. Next up, we've got exponential. So here we go. First one, y equals 1/2 all to the x minus 3. Go ahead and pause this video and give this one a shot. Okay, here we go. Descriptive form. It's already in descriptive form. I have nothing to add or subtract to the other side. So my initial point, x coordinate is positive 3, y coordinate is 0. Remember with exponential that is my asymptote that we just found at 3, 0. Okay, so to make that distinction, I'm going to go ahead and put my asymptote in purple. So 3, 0. And here's my asymptote just coming right alongside that x-axis. Okay. Now we need 2 more points, so we're going to plug in. I'm going to go ahead and choose to plug in 3 initially. Okay. That gives me 1/2 to the 0, and anything to the 0 is 1. And so my first coordinate point is that when x is 3, y is 1. When x is 3, y is 1. Then you have to choose what else you want to plug in. You could plug in 2 or 4, or technically speaking, whatever. For the sake of this video, I'm going to plug in both 2 and 4 so that no matter which one you chose, you have something you can check against. Okay, if I plugged in 2 into my exponential, we'd have 1/2 to the 2 minus 3 is negative 1. And a negative in the exponent spins that fraction. And so I have an ordered pair when x equals 2, y is 2. Okay, If I plugged in 4, y equals 1/2 to the 4 minus 3. Well, that would give me 1/2 to the 1, which is 1/2. And so I have another ordered pair if you prefer at x equals 4, y equals 1/2. And technically speaking, you could still plug in other ones. For example, if you plugged in x equals 1, you'd get y equals 4. Or if you plugged in x equals 5, you'd get y equals 1/4. Okay? As long as you have enough to get that sketch of your exponential, you're good to go. Okay? There you have it. Okay, next one. We have y equals -2 times 3 to the x minus 1 plus 3. Go ahead and pause the video and give this one a shot. Okay, descriptive form. Let's subtract this 3 to the other side. Y minus 3 equals -2 times 3 to the x minus 1. My ordered pair then, x is 1, y is 3. That's my asymptote. X is 1, y is 3. Oh, let me put that in purple. Make a distinction between the asymptote and the rest of the graph. Then you have to plug in 2 points. I'm going to go ahead and plug in 1 first. So y equals -2 times 3 to the 1 minus 1 plus 3. -2 times 3 to the 0 is 1 plus 3. And -2 plus 3 is 1. And so my first coordinate point here is that when x equals 1, y equals 1. Let me write that. When x equals 1, y equals 1. Okay? And then you have to pick what other point you want to plug in. So I'm going to go ahead and plug in 2. -2 times 3 to the 2 minus 1 plus 3 is -2 times 3 to the first plus 3, okay, which is -2 times 3 plus 3, or -6 plus 3, which is -3. Okay, and so when x equals 2, y equals -3. X equals 2, y equals -3. Okay. And with that, you can sketch out your exponential function. Now, if you hadn't plugged in 2, say maybe you plugged in 0. Okay, if you had plugged in 0 here, you would have had -1 in the exponent, which would cause this 3 to become 1/3. -2 times 1/3 is -2/3. And plus 3 would become 2 and 1/3. So for example, if you plugged in 0, you'd have a point at kind of right about there. And so on and so forth. Depending on what you plug in, it's going to change what points you are able to plot. Oops, sorry. Let's bring this one through this point. Okay, it changes what points you are able to plot, which changes your sketch just a little bit, but all sketches result in the same exponential function. Okay. Okay, one more here of our exponential. Let's go ahead and graph. Y equals, oops, sorry, I'm getting ahead of myself. That's a piecewise. Y equals 3 times 1/3 to the x plus 2. Go ahead and pause this video and give this one a shot. Okay, here we go. Descriptive form, subtract this 2 to the other side. 3 times 1/3 to the x. Pulling out my initial point, x is 0, y is +2. That's my asymptote. Okay? And so we are here. So my asymptote is at 0, 2. Plugging in values then. I'm going to go ahead and plug in 0 first. We have y equals 3 times 1/3 to the 0 plus 2. Okay, 1/3 to the 0 is going to be 1. 3 times 1 is 3. And 3 plus 2 is 5. And so I have an ordered pair at x equals 0, y equals 5. Okay. And then you have a choice to make. You can plug in -1, you can plug in 1, or something else. So say we plugged in 1. Y equals 3 times 1/3 to the 1 plus 2. 1/3 to the 1 would be 1/3. 3 times 1/3 is 1. And 1 plus 2 is 3. So I have an ordered pair that when x equals 1, y is 3. Right here. Okay. If you had plugged in -1, -1 would spin this fraction, cause this 1/3 to become 3. 3 times 3 would be 9. Plus 2 would be 11. So when x is -1, y is 11. So that would put us pretty far up on our graph here. Yeah. That gives us our exponential, or a sketch of our exponential. Okay, piecewise, everybody's favorite. I've got 2 of these. Okay, so we have y equals 4x minus 2 when x is less than or equal to 1, and x minus 1 quantity squared plus 4 when x is between 1 and 3. Okay. Go ahead and change this comma to an if. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so we have 2 functions here that we are going to have to work with. Let's go ahead and do our linear one first. So y equals 4x minus 2. This is in slope-intercept form, so if you'd rather graph in slope-intercept form, that's totally fine. I'm going to go ahead and turn it into our descriptive form. Now before I do so, let's go ahead and make sure we take note for this function, where are we starting and ending? Okay, well for this function we're going to have a value at x equals 1, and then we're going to do everything less than 1, everything towards negative infinity. And then is this going to be a point or a hole? It's going to be a point because there's an equals. Okay? So turning this into descriptive form, knowing that I'm going to start at 1, have a point, and go to the negative side. Adding the 2 over, we are here. So my initial point, x is going to be 0, y is going to be -2. I do have a slope of 4. So we're going up 4 over 1. Okay, so let's go ahead and come on over here and take a look at what we've got. Okay, I've got my initial point at 0, -2. X equals 0 is inside that domain, so I'm good to go. And then up 4 over 1. And I do have a point at 1. However, I'm not going to keep going because 1 is the largest that I go here. I could go down if I wanted to in the opposite direction. But there's the first part of my piecewise. Okay, second leg, we have y equals the quantity of x minus 1 squared plus 4. Before we turn it into descriptive form, let's make sure we notice that we are starting at 1 and ending at 3. At 1, we have a whole, and at 3, we have a point. Okay, so descriptive form, let's subtract this 4 over. Pulling out our vertex, x is 1, y is 4. And then we are doing a quadratic, so we're thinking a over 1, which is 1 over 1 for this guy. So initial point at 1, 4. Now I do have a whole there. Make sure we're always paying attention to the whole and point bit. Okay, so 1, 4, I'm going to have a whole. And then I'm going up 1 over 1, but only in the direction of 3, right? Now, if you want to know where to end, it could potentially be helpful, since we know we are ending at 3, that this isn't going to keep going indefinitely. It could be helpful to actually plug 3 in to my equation to see what I get. That way I know kind of where I'm ending. Okay? 3 minus 1 is 2, squared is 4. 4 plus 4 is 8. So if I plug in 3, x equals 3, I get y equals 8. Okay, which is technically speaking here. Okay, so there's my quadratic. Okay, I've got one more for you. There's several on the other review video as well. Do y equals, and we have negative 2 to the x plus 3 minus 1. If x is between negative 2 and 0. We have 1 if x is greater than or equal to 0 but less than 2. And we have 1/2 times x minus 4, the quantity of x minus 4 squared, if x is greater than or equal to 2. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so here we go. 3 functions. Okay. You can do them in any order you want, but this guy looks, the middle one looks the most friendly to me, so I might recommend starting there. Y equals 1 is a horizontal line. Y equals 1 is going to start at 0, it's going to end at 2. At 0 we'll have a point, and at 2 we'll have a whole. Okay, so let's go ahead and sketch that. Okay. At 0 we will have a point, at 2 we will have a whole. And so there's the first part of that piecewise. Okay. Second, you can do whichever one you want. I'm going to do the quadratic next. So we have y equals 1/2 times the quantity of x minus 4 squared. Okay, it's already in descriptive form, so my hk, my x is going to be positive 4, my y is going to be 0. For this one, my quadratic is going to start at 2 and is going to go all the way to infinity, and I'm going to have a point at 2. X equals 4 is inside that domain, so I can go ahead and plot that quite confidently. And then for quadratic, we know we are going up a over 1 or down a over 1 as the case may be. So in this case, it is 1/2 over 1. Okay, so we are here. Now that does not keep going. This quadratic does not connect to that whole, because remember the quadratic increases as we work our way around our quadratic. If you want to know, so this is actually going to end up above this point, if you want to know where that point is, like what actually happens at x equals 2, if you take this 2 and plug it in, you can find out. So 2 minus 4 is negative 2, squared is 4, times 1/2 is 2. When I plug in 2, I get 2. And so that tells me where my quadratic is stopping. And it keeps going all the way to infinity. Okay. Oh, sorry, that ended up a little bit off the screen. Let me zoom out here a little bit. It's going all the way to infinity over here. Okay. Last but not least, we have our exponential y equals negative 2 to the x plus 3 minus 1. Okay, so I'm only going to be looking at the piece between negative 2 and 0, which are going to have holes at both of them. Now you have a choice to make here. Technically speaking, negative 2 to 0 is a pretty small region, right? It's 3 points. So you could, if you wanted to, just individually plug in negative 2, plug in negative 1, plug in 0, plot those 3 points, making sure that you have holes at the outsides at negative 2 and at 0, but plot those 3 points and then connect them. And you might prefer that method. Or you could graph this exponential like normal, which is turning it into descriptive forms. Let's add the 1 over. We can pull out our initial value of x equals negative 3, y equals negative 1 for my asymptote. And then I need 2 more points. Again, you have a choice to make here. Usually we plug in negative 3 as our first value. However, negative 3 is not in this interval. So if you do that, you're going to need to make sure that you sketch the point, but don't do x equals negative 3 very dark, because you're going to have to erase it at the end. It's not part of the domain, so you can't leave x equals negative 3 on the graph if you choose to plug in negative 3. Your other option would be to plug in negative 2 and 0 as your 2 other points, because it gives you that outline of your exponential. It is totally your choice. For the sake of the video, I'm going to plug in negative 3, negative 2, and 0, so that you can check, hopefully, you can check the one that you chose. Okay, so let's plug in negative 3 first. We have y equals negative 2 times negative 3 plus negative 2 to the negative 3 plus 3 minus 1. Okay, well, negative 3 plus 3 is 0. 2 to the 0 is 1. And negative 1 minus 1 is negative 2. Again, if you're going to plot the point x equals negative 3, y equals negative 2, which would be right here, you would need to do that really lightly, and you need to make sure you erased it at the end, because the only part that it can actually show is between negative 2 and 0. Okay, if we plugged in negative 2, we have negative 2 to the negative 2 plus 3 minus 1. Which is negative 2 to the negative 2 plus 3 is 1 minus 1, which is negative 2 minus 1, or negative 3. So when x equals negative 2, y equals negative 3, and that's going to be a hole. Okay. And then last but not least, I'm going to go ahead and plug in 0. Let me do that here. Y equals, we have negative 2 to the 0 plus 3 minus 1, which is negative 2 cubed minus 1. 2 cubed is 8, so we're at negative 8 minus 1, which is negative 9. And so I have another ordered pair at x equals 0, y equals negative 9. And that's going to be a hole. Okay. Now, unfortunately, my graph's going to go a little bit into my work here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so for the sake of not having to mess up my work, pretend for a second that the scale stays consistent. So we're here at negative 3, and I'm going to go 4, 5, 6, 7, 8, 9. Just to help get that negative 9 on the graph. So that we can see our exponential there. Again, negative 9 would technically be down here a lot further. And I do apologize about that, but your graph should look something like that. Okay? Okay, composite functions. Okay, I've got two of these. Give me a quick second to pull these up. Okay, first up, we've got find f of g of x. I'm going to have f of x equals, and let's do 8 to the 4 minus x plus 3. And g of x is going to be negative x minus 1. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so here we go. This composite function, we have g of x getting plugged into f of x. And so I'm going to take this g of x and I'm going to plug it into f of x. Okay, and so my f of g of x is going to be 8 to the 4 minus, and then I'm subtracting negative x, so it's going to be plus x, and I'm subtracting negative 1, so that's going to be plus 1 plus 3. And so this composite function is 8 to the 4 plus 1 is 5, so x plus 5 plus 3. You also could graph this one. I'm not going to on this video, but if you would like to, you're more than welcome to, and you can also send it to me to check your work if you would like, or you can show it to me in class, whichever one you prefer, okay, if you're wanting to graph it. Okay, second one and final one for composite functions here. Let's go ahead and find g of f of x, okay, and we are going to have g of x equals negative 5 halves times the absolute value, absolute value of x plus 4 minus 2, and f of x is going to equal x minus 6. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, and so here we go. This composite function, we have f of x getting plugged into g of x. And so my f of x here is going to get plugged into g of x. Oh, I apologize. I mean, it doesn't make a huge difference, but I did want this to be a minus. So if you already worked through it with the plus, that's fine, but I did want this to be a minus because I want to make sure we're practicing the negative idea here. Okay, if you need to pause the video and redo this one, that's fine. Okay, but I'm plugging f of x into g of x, so my function is g of f of x equals negative 5 halves times the absolute value of, plugging in x, we have x minus 6 minus 4 minus 2. Okay. And the reason I wanted us to look at this one is because when you simplify there, negative 6 minus 4 is what? We should say negative 10. It's very tempting to want to say minus 2 because people see 6 minus 4 and want to say 2, but this is negative 6 and negative 4, which makes negative 10. Okay? Okay, let's go ahead and do some quick transformation reminders here. You have some in your homework tonight as well. xy, if I told you that xy was becoming, let's do negative xy plus 5. What is that telling me to do? How is that telling me to transform the function? Okay, this is telling me because x is changing sign but y is staying the same, this is telling me to reflect across the y-axis, and then plus 5 is telling me to go to translate up 5. Okay, let's do another one of those. xy becomes, and let's do x plus 3 negative y minus 6. Go ahead and pause the video, give this one a shot. What's this telling us to do? Okay, this x plus 3 is telling me to translate right 3. Because the x is staying the same, but the y is changing sign, it's telling me to reflect across the x-axis. And then, because we have minus 6 on the y, this is telling me to translate down 6. Okay, and then 2 other questions real fast here. What's the other way I could say, or to show the negative x besides like this? And what's the other way I could show the negative y besides like this? Okay, we also could show our negative x like this. We also could show our negative y like that. Okay. Okay, last but not least, we have some evaluating for our piecewise. So I'm going to go ahead and bring back our piecewise here that we had. There it is. Actually, you know what? Let me just come up with a new one. Okay. Okay, I'm going to give you a piecewise function here. Let's use this one. F of x equals, and we're going to do absolute value of 3x plus 1. When x is less than or equal to 2, and 5x minus 6 when x is greater than 2. Okay, and I'm going to ask you a couple of questions about this, then I'm going to give you another piecewise so you can practice a couple more. Okay, so let me ask you, what is f of 2? What is f of negative 4? And what is f of 6? Go ahead and pause the video, give those a shot, restart it when you are ready. Okay. Okay, f of 2, I want to know what happens when x equals 2. Well, looking at my inequality, which one applies to x equals 2? Well, there's x equals 2, so I'm using this function. Absolute value of 3 times 2 plus 1, which is the absolute value of 6 plus 1, or the absolute value of 7, which is 7. Okay, f of negative 4, where's negative 4? That's this top one, negative 4, plugging that in, we have absolute value of 3 times negative 4 plus 1. 3 times negative 4 is negative 12, plus 1 is absolute value of negative 11, which is 11. And last but not least, we have 6. So where is 6? 6 is here. So we're using the bottom function this time. 5 times 6 minus 6 is 30 minus 6, or 24. Okay? And then let me give you one more to try, in case you struggled a little bit with that one, want to give it another go. Let's do f of x equals, and let's do this function. Okay, we have 2 to the x plus 1 when x is greater than 2. We have negative 3x plus 5 when x equals 2. And we have the absolute value. Actually, we did an absolute value last time. Let me change this question just ever so slightly, give you a chance to practice something else. Let's do an x squared. Let's do x plus 3. We'll do x plus 3 squared when x is less than 2. Okay, so I'm going to ask you, what is f of 2? What is f of 3? And what is f of negative 1? Go ahead and pause the video and give these a shot. Okay, f of 2, asking what happens at x equals 2. That's right here, so I'm using this guy. Negative 3 times 2 plus 5, which is negative 6 plus 5, or negative 1. Okay. Whoops, I put that on the wrong one. Put that on 3 on accident. Let's just switch these. There we go. F of 2 is negative 1. F of 3, which one corresponds with f of 3? Well, that's this guy here, because 3 is greater than 2, so we have 2 cubed plus 1. 2 cubed is 8, plus 1 is 9. And last but not least, we have f of negative 1. Where is negative 1? Negative 1 is in this interval here, so we have negative 1 plus 3 quantity squared. Negative 1 plus 3 is 2, squared is 4. Okay, so there's this video here, there's the other video, and then there's another review video that I already made, and then there's going to be a third video where I'm walking through writing equations. So if you are sitting there wanting some extra practice or some explanation on writing equations, find the writing equations video and take a look at that one. Okay? Good luck studying!